I'm going to go over a few problems from section 5 of chapter 8. I know that video is a little sketchy on YouTube, so I'm going to put this in as an additional video. Question number 1 says solve the inequality and graph the solution set. And the inequality is b plus 4 times b minus 8 is greater than 0. In order to solve these, we need to set each of these factors equal to 0. And that will be the points on the number line that divide the number line into 3 sections. If you had 3 of those factors, it might divide the number line into 4 sections. What we need to do now is we need to test a number from each of these sections to see if it makes this original equation true or false, or original inequality true or false. So I'm going to test -5, I'm going to test 0, and I'm going to test 9. And I'm going to see if it's true or false in each section. So this would be -5 plus 4 times -5 minus 8. Is it greater than 0? -1 times -13 is positive 13. Is that greater than 0? Yes. So in this section, it is true. Test 0. 0 plus 4 times 0 minus 8. 4 times -8 is -32. So if I'm checking to see if it's greater than 0, the answer is no, or false. So it's false in this section. I'm going to test 9, and it'll say 9 plus 4 times 9 minus 8. So that is 13 times 1. 13 is greater than 0. So this one's true. So I got true, false, true. Okay? So when that happens, you're going to need to choose the part of the number line that's true. And on this particular question, they're going to want you to shade this part of the number line and this part of the number line. Now we need to talk about if we need an open circle or a closed circle. And since this is strictly greater than, we need an open circle here and an open circle here. On your computer, that's going to look like a parenthesis. Okay? They're going to use a parenthesis. If you needed to color in the circle, they would use a bracket. So the answer for that question it's hard to see. My printer didn't print real well, but that's what the answer would look like, would be C, but it looks like this. This is what answer choice C would look like. Parentheses, shading to the left. If they wanted interval notation, then I would write it this way. -infinity to -4 in union with 8 to infinity. And again, I use the parentheses here because of the notation. And I always use a parenthesis on infinity. So that's question number 1. That's how you do those type problems. Question number 5 is the next one I'm going to go over. And question number 5 says 21x squared plus 4x is greater than or equal to 1. This is what it looks like when I printed it off the homework set. Now your problems may not have these same numbers. They may be similar numbers. They may or may not be the same. Let me check the focus here. It's autofocus. Let me see. Is it really as good as it can get? Oh, to me that looks a little bit better. Okay. So I need to move the 1 over to the other side. So I'm going to subtract 1 from each side. So it's going to say 21x squared plus 4x minus 1 is greater than or equal to 0. And then I need to factor And this is going to factor into 3x and 7x. And it's going to be plus 1 minus 1. So I'm going to set those equal to 0 because it's going to determine my boundaries on my number line. So it says 3x plus 1 is 0. Solve that little equation. Okay, 7x minus 1 is 0. Solve that little equation. So my number line is divided at negative 1/3 and 1/7. Those are the numbers. I need to decide if it's true or false here, true or false here, true or false here. You need to pick some test points. Now, just because you had fractions in your problem doesn't mean you need to pick fractions for your test points. I would pick really easy numbers to work with. I need one number over here, so I'm going to test negative 1. I need a number in here, since this one's negative and this one's positive, I'm going to test 0. And then I need a number over here, so I'm going to test positive 1. I'm going to go back to the original equation that says 21x squared plus 4x is greater than or equal to 1, and I'm going to see if it's true or false for each of my test points. So I'm going to start with negative 1. And I'm checking to see if this is true or false. Okay, I paused and I turned it back on. I hope this doesn't affect the quality of the recording. Every great once in a while when I do that, I forgot that it did, but maybe it won't. If it does, y'all let me know and I'll pick back up with number 5. I'm going to plug that in. This is going to be 21 times 1 minus 4. 21 minus 4 is 17. So let me get this going here. I'm going to pause it again. Hello? Okay, so this one was true. I've tested the second one and it is false. So I'm going to test the positive one over here. 21 times 1 squared plus 4 times 1, is it greater than or equal to 1? Is 25 greater than or equal to 1? And it is true. So when you shade your number line on this problem, it had an underscore. So you're going to use a colored in dot or a bracket, and you're going to shade everything this direction. And again, it had an underscore, so the same thing happens here. If you want interval notation, we're going to say it's negative infinity to negative 1/3 in union with 1/7 to infinity. Okay, and that's problem number 5. The next one I want to look at is problem number 9. Let me find it here. There's 5. We've done that. Let's look at number 9. As you look at number 9, it appears that you got to start off by foiling out this and then maybe moving the 9 over. And I did that on a notebook to show you what it would start out and it would look like. And if you foiled that out and then you moved the 9 over, you'd end up with 49x squared minus 42x plus 18. And you could use the quadratic formula and you could work through this, but I want to go back and look at the original problem. The original problem says, if you square this item, will it be greater than or equal to negative 9? Now guys, you know when you square something, it's always going to turn out to be, at the very least, 0, but it's more than likely it's going to be a positive number. So it will always be greater than or equal to negative 9. So on question number 9, when this is the situation, be careful on that and know that your answer is all real numbers, and I'm going to look and see exactly how they indicate that on here, because I want you to know that they're going to use interval notation, and it's negative infinity to positive infinity. Okay, that's our answer there. So be careful on 9, 10, and then look at 11. Number 11 is the same type of problem, but they've turned it around and they've said, we want to know what values of x will cause this expression, when squared, to be less than or equal to negative 9. Well, anytime you square a number, the answer is positive or 0. So it's always going to be greater than that. It's never going to be less than or equal to negative 9. So this is no solution. Okay, so be careful on those. After number 9 and number 11, I had number 13 marked to work. So let me get some paper out here and I'll get 13 worked for you. 13 has 3 parts. It's worked just like those with 2, except you have one more step. And the question says x plus 7, this is number 13, times x plus 3 times x minus 6 is less than 0. So we set each equal to 0 to find our numbers that are important on our number line. And we draw our number line, and we have negative 7, negative 3, and 6. So I need to test a point from each of those sections. So I will start off by testing negative 8. So negative 8 plus 7 times negative 8 plus 3 times negative 8 minus 6. When is that less than 0? Negative 1, negative 5, negative 14. So if you multiply those together, you are going to get 70, and it's going to be negative because you have 3 negative numbers. So negative 70 is less than 0, so it's true. Okay. And the next one, we're going to substitute negative 5. Let's test negative 5. So negative 5 plus 7 times negative 5 plus 3 times negative 5 minus 6. That is positive 2 times negative 2 times negative 11. So that's negative 4 times negative 11. That's 44. Is that less than 0? No. So in this part it is false. In here I'm going to test 0. 0 plus 7 times 0 plus 3 times 0 minus 6. So 7 times 3 times negative 6. 21 times negative 6 is negative 126. So it's true here. It is less than 0. And so I'll also test 7. 7 plus 7 times 7 plus 3 times 7 minus 6. 14 times 10 times 1 is 140. Is it less than 0? No, it's not, so it's false here. So for interval notation, this answer is going to be negative infinity to negative 7 with a parenthesis because it's not underscored, in union with the section from negative 3 to 6. For the number line, you're going to shade this part with a parenthesis and then shade this part with parentheses, and that's number 13. Okay, number 17 is another one I had indicated that I wanted to go over with y'all. And on number 17, the problem says, let me find my paper here, x plus 5 over x plus 6 is greater than 0. So what you need to do here is set the numerator equal to 0. And it could be negative 5, and set the denominator equal to 0. Negative 6. Now those are the numbers that are going to divide my number line. Okay? So we're going to test some numbers here. and we want to test negative, I got those backwards, negative 7. So negative 7 plus 5 over negative 6, 7 plus 6. That's negative 2 over negative 1, which is 2. Is that greater than 0? Yes, so this part's true. I'm going to test the number between those. I'm going to test negative 5.5. So negative 5.5 plus 5 over negative 5.5 plus 6. And that's going to be negative 0.5 over positive 0.5, which is negative 1. Is that greater than 0? No. So in here it is false. And then I'm going to test 0. 0 plus 5 over 0 plus 6 is 5 over 6. Is that greater than 0? Yes, that part is true. So here's my shading here. Here's my shading here. Interval notation would be negative infinity to negative 6 in union with negative 5 to infinity. Okay, and that's an example like number 17. If you have any questions, please send me an email. This video has ended up being longer than I anticipated, but I hope it helps you out. Thanks.